Hey kiddos, this is Unit 10, Circles. So here's a nice piece of artwork by Natalie Kandinsky for your viewing pleasure. You can find lots more circle art on the internet because circles are used in lots and lots of different art from lots and lots of different cultures. Awesome. So here we go. Area and circumference. Today our goal is to use geometric formulas to solve problems involving circumference, arc length, area of a circle, and area of a sector. So what does it mean to have an exact answer? So in short, exact answers have no decimals. No decimals whatsoever. So even though we're tempted to use 3.14 for pi or to hit the pi button on the calculator, do not do that if we want exact answers. Because when you round, rounding means estimating. So if you think about when you round a number, you could have 3.27, or your neighbor might have 3.2794, and someone else may continue it out to 6 decimals, and all of a sudden those are not exact answers, they're estimated answers. So it's important as you proceed through math that we understand what an exact answer is. So I want you to take a minute and I want you to look at these 5 different answers, and I want you to circle the ones which you believe are exact answers. All right, so if I look at these and I determine what I think are exact answers, 14 pi is exact because everyone will have the same thing. B is rounded, so we cannot have that decimal. C is ugly. It's exact, but it's not in reduced form. We do not like having that square root of pi in the denominator. So in order to get that square root of pi out of the denominator, you would have to do something like multiply by square root of pi over square root of pi, which would give you 27 over 3 pi, square root of 3 pi over pi. Since the pi in the denominator is not under a radical and the pi in the numerator is under a radical, then we cannot cancel those out. So this is exact and reduced, and the first one, it's technically exact, it's just not reduced. All right, D is exact, no decimals. E, not exact, because you have 14.3, which is really 14 and 3/10. Or you could make that 143 over 10, and there's a pi in the denominator. So that can technically be changed to an exact answer if that's technically the decimal. Now, we don't know that. It could have been 14.318, and we would have just rounded to 3. So be very cautious on your answers. For this particular assignment, they want exact answers. All right, area. So if we had to come up with a great definition of area, it's basically what's on the inside. So it would be like, what are we painting? And the formula for area, which you guys learned back in elementary school, is pi r squared. Just a little note, if you think of area, area is always in units square. And if you notice, the answer has a square in it and the formula has a square in it. Crazy town. All right, circumference. It's like how far can you walk? So how far, I always say does an ant walk? So the circumference would be what we have in blue around the circle. So how far does the ant walk? The ant walks around the circle, ant walks around the circle, and if you had a bendable ruler, you could measure that with a bendable ruler. We talk about circumference, and the formula for circumference is 2 times pi times r. If we take and manipulate that formula and just put the 2r together and the pi, we know that diameter is 2 times the radius. So in essence, we get 2 pi, or diameter times pi, and a circle, the area is in units. Just units, not units squared. And if you notice, the r is not squared in the formula. All right, so if we want to find the area of a circle with diameter 18 feet. So the first thing we have to realize is they gave us the diameter was 18 feet. I'm going to encourage you, if you don't know where to start with your formula. Our area is pi r squared. So in order to use this formula, I definitely need the radius. So if I look at the information given to me, they actually gave me the diameter, but I know because I am so smart that the radius is half the diameter. So half of 18 is 9. So for this one time only, I'm going to put the units here because I want to show you something for those of you who get confused about formulas and units. So if we put in 9 feet and we put 9 feet, and I continue to work this out, I get pi. 9 times 9 is 81, and feet times feet is feet squared. So if you are not good with units and you want to put the units in the problem to help you out, you can do that. Now, if we clean that up, most people will write the number and then put the pi, and we're going to leave our answer as 81 pi feet squared. Okay, let's look on to example 2. Example 2, the circumference of a bike tire is 60 inches. So if I'm thinking of a bike tire, the distance around is 60 inches. It says, what is the radius of the bike tire? So they gave us their circumference, and I know that circumference is 2 times pi times my radius. They told me in this particular problem that my circumference is 60 inches. Those of you who get confused easy or who don't think you're great problem solvers, sometimes it will help you to circle what you're looking for. So in this particular problem, I am looking for r. I need to isolate r and get it by itself, which means everything else must go to the other side. I'm taking 2 times pi times r, so I'm going to take and divide this by 2 pi, and I'm going to take and divide the left side by 2 pi. So those reduce to 1 and cancel out. 60 divided by 2 is 30, and I cannot do anything with pi. My units is inches, and that's going to equal my radius. And I can just leave it like that. I know it's not pretty, and it doesn't look like something that's going to make you happy, but it will make your math teacher happy. So just leave your answers exact. Okay, so example 3. It says find the exact circumference of a circle if the area is 4.8 inches squared. So, first of all, they have given me area. So I know that area is pi times r squared. So if I take 4.8, which is the area they gave us, and this is pi r squared, I'm going to have to divide by pi. And I'm going to take in my calculator, and I'm just going to go ahead and put 4.8, and I'm going to convert that to a fraction. So this is really 24 over 5 pi equals r squared. I have r squared, and in order to undo the power of 2, I'm going to come in and take the square root of the problem. So square root of both sides leaves me with the square root of 24 over the square root of 5 pi, and that equals my radius. I can simplify the square root of 24, so if I come up here, the square root of 24 is 4 times 6. We cannot lose the square root of 5 pi in the denominator. The square root of 4 is 2. I cannot do anything with the 6. And I'm going to bring down my 5 pi. So now I can't have the square root of 5 pi in my denominator, so I'm going to go ahead and rationalize that denominator and multiply by the square root of 5 pi over the square root of 5 pi. So in my numerator, I can multiply numbers that are underneath the radical, so let's multiply the 6 times 5 to get the square root of 30, and that pi also stays underneath the radical. And now I have the radius. 2 square root of 30 pi over 5 pi. Unfortunately, we are not done with this problem because if you look, it says find the exact circumference. So I'm going to come over here, and my circumference is 2 times pi times my radius. So if I take 2 times pi times my big, ugly radius, As I look at this problem, some of you really need to think of this as 2 pi over 1. So you have a pi in your numerator and you have a pi in your denominator, so those 2 pi's will cancel out. In my numerator, 2 times 2 is 4. I cannot do anything with the square root of 30 pi. And in my denominator, I'm simply left with the 5. Because the units of my original problem was inches squared for area, that means my circumference is going to be in inches. Okay, so we're going to take this a step further today. We're going to talk about area of a sector versus arc length. So remember, area is something that you can paint. Okay, so how much paint, how many gallons, how many square inches or square feet could a can of paint cover? So when we talk about a sector, what we're really talking about is kind of like a piece of pizza or a piece of pie. So you can take a highlighter, a colored pencil, or even your regular pencil. That right there represents a sector. So what we need to remember about a sector is you have an angle in here. So whatever degrees this is a rotation, and this is the measure of your angle from here to here. So that means there are 30 little, or however many, little tick marks here representing how far we rotate. When we look at the formula for area of a sector says we're going to take this angle measure over 360 because that is the part of the circle that we are looking for over the whole entire circle, which really in the end is a percent. So if I have 62 out of 360 degrees, what percent of the circle am I looking at? When I talk about area of a sector, this little formula here, part of the formula, should look familiar because pi r squared is just the formula for area of the entire circle. So really, it's what part of the whole area are we looking for. So arc length is somewhat related and somewhat not related. So arc length would be, if you're an ant, how far would you crawl along to get from one point to another? And again, you do need the angle measure in order to find that. So how far we rotate from one point to the other. This could be like the length of your pizza crust or the length of your piece of pie, whatever food brings you joy. So again, we are taking angle over 360. So this right here is what part of the circle times the whole circumference. And if you think of it that way, it's really probably the easiest way to think about it. So let's do a couple examples. Example number 4. Find the exact arc length of a circle with area 49 pi centimeters squared and central angle measured to 178. Use the picture and highlight what you are finding. So we have to decide, are we finding arc length or are we finding area of a sector? And they want us to find arc length. So 178 degrees would mean my ant starts here and crawls almost halfway, but not exactly halfway around this circle. So if I think about my formula, my arc length, which they denote by the letter L, just because they like to make things confusing, it's my angle over 360. And because this is part of the circumference, I'm going to use the 2 pi r. So when I look at the formula, I have my angle, so that's good because I have 178 over 360. But when I come to fill this part of the formula in, 2 times pi, I'm actually missing the r. So I am going to have to find r. Good news about r is they gave me the area. So my area is 49 pi, and that equals pi r squared. Ultimately, I need to get r by itself, so I'm going to divide each side by pi, so the pi's cancel. So I have 49 equals r squared. To undo the square, you take the square root of each side, so my radius is 7. I can now take that 7, and I can come over here, and I can substitute it into my formula. Now, from here, some of you would like to reduce by hand. I'm not saying you can't use a calculator. I'm just saying don't put pi in your calculator. So right now you have 178 divided by 360 times 2 times 7. And if you do put that in the calculator and you have a multi-view, you're going to hit that little double arrow button, and you are going to get 623 over 90. You could put the pi out to the right, or you could take that pi and put it in the numerator. However, the pi cannot go in the denominator. The unit for this area was centimeters squared, which means our arc length is one-dimensional, so it's going to be in centimeters. Coming up on example 5, this says the area of the shaded area is 28 square inches. So when I look at this picture here, this is 28 square inches. Find the exact diameter of the circle. So they try a little trickery on this problem because they gave you 108 degrees, but ultimately I need to know how far I'm rotating around to go from here to here. So if I take 360 and I subtract out that 108, this part of the circle is really 252 degrees. So if I think about the area of the sector formula, it's my angle over 360 times pi r squared. So my area, they told me it was 28, and that's going to equal the part of the circle that I'm looking at, which is 252 degrees over 360 times pi times r squared. Now, our goal is to solve for r, the radius, because I need the diameter, and in order to find that, I need to find the radius. So for me, I'm probably going to do this first. I'm going to multiply each side by 360. So the 360s cancel out. So in my calculator, if I take 28 times 360, I get, what do I get? I get 10,080. And that equals 252 pi r squared. So now I can divide by 252 pi. So if I divide by 252, oh wow, I get exactly 40. And that is over pi because I have not done anything with the pi. So r squared says take the square root of that. So ultimately, I have the square root of 4 times 10 over the square root of pi. The square root of 4 is 2. I cannot break down to the square root of 10. And I need an exact answer, so I'm going to rationalize my denominator. So looking for a pretty ugly looking answer that makes your math teacher happy. So this is my radius, and my radius is going to be in inches because of the unit that was tied to the original problem. The issue with this problem is they want the diameter, so my diameter is 2 times my radius. So if I take 2 times that, I'm going to get 4 square root of 10 pi over pi, and that's still going to be in inches. And this is your exact final answer. Okay, moving on, example 6. These are just some questions for thought that you should be able to answer after listening to this awesome video. So I'm just going to let you go through and answer those. And if you have questions, you can ask in class. Have a wonderful afternoon, and I will see you soon. Have a great night.